I think we can start. Hello everyone. This is the third week of Introduction to Data Analysis class. In the first week, we introduced the course. We said we will be talking about data analysis and statistics throughout the semester. And last week was the introduction to the key concepts of statistics. So I said this is going to be more like a dictionary because you will be hearing lots of terms and new concepts. So we talked about the difference between descriptive statistics and inferential statistics. We talked about the notion of variables, how to construct good variables, the properties of variables, like the categories have to be mutually exclusive and collectively exhaustive. We talked about different levels of measurement. The nominal level, ordinal level, interval ratio level, and the dummy dichotomous variables. We talked about the importance of unit of analysis. So how the difference in unit of analysis actually affects the kind of the research that we are doing. It can affect our conclusions as well, and how the same kind of research can be done using different units of analysis. We talked about the difference between reliability and validity, some measurement issues, how to measure some of these variables is an important step, because if you cannot measure the variables in a reliable and valid way, then whatever statistical analysis you do will not be helpful at all. They will be misleading. You first need to have good variables to be able to analyze them. And then we are still trying to learn these things. And this week, we will build on what we learned in the previous weeks. So what data analysis and statistics is, and some of these main key concepts. But we will start learning about some of the ways in which we can represent these variables. We can represent the data in these variables. If you did the preparatory videos for this week, they prepare you for today's lecture. They introduced you some certain kinds of charts and graphs. The videos talked about the pie charts, the bar charts, the line graph, and histograms, these kind of things. And today we will talk about them. And I will do my best to link them to the things you have already learned in this class. Okay, so we will be also reviewing some of the things we learned in this class before. Now, this is a strange lecture for me, because usually when I teach this, I do a hands-on exercise, because when I teach this course face-to-face, I also reserve a lab time, and we go to the lab and I teach you statistics softwares like SPSS package or Stata. I teach you a software how to do this analysis. In the introduction I told you 2 weeks ago, I thought about this very hard, because I still want you to teach some of these things, but also I think these online lectures and online classes and also the time period that we are living in with this COVID-19 crisis and everything, it's not going to make your lives easy to be able to connect to these softwares via digital labs and etc. That's why I decided this year I'm not going to teach you them directly. So you will not be responsible for them. But then it makes it difficult for me to teach some of these things. So what I decided to do today, I will be, instead of using a PowerPoint, I will be using Microsoft Excel, a simple tool. In most of your computers, you will find Excel. And if you don't have, there are free versions of it in Macs. You have a version for that. If you go sheets.google.com, if you have a Google account, you will use a Google-based free version of it. And I'm just going to use Excel to teach you some of how to construct these graphs. And I'm not, my main goal is not to teach you how to construct them, but when I try to make some points, I will be doing it myself so that you can see how I construct these graphs. And if you want to learn, you can learn. If you don't want to learn, you don't. And this will be very basic things that if you want to pick up on, you can practice yourselves on. Shoot me an email. I will be glad to help you with these. Okay, so one of the key things I want to emphasize is the kinds of graphs you can choose. It depends on the kind of variables you are dealing with. It's not simply a choice. There's a part that there might be some choices that you will be making, but actually you're not free to choose anything you want because some of the properties of these variables already tell you the kind of graphics that you can use. That's why in the videos, it started, the first video was, for instance, about the qualitative variables. Like if you have what are the qualitative variables? Let's say if you have a nominal variable. So what can you do? For instance, if you have a nominal variable, you cannot use a histogram because histograms are for interval ratio variables. If you have a nominal variable, just words, let's say, what's your race? Ethnicity and race. Let's say if are you black or are you white? Are you Asian? Are you Hispanic? You cannot make a histogram about this. You cannot make a line chart about this. So you can make a pie chart, or maybe you can do a bar chart, and I will show you. And today I will talk about this a little bit. But if you have a nominal variable, you can choose between a pie chart or a bar chart. And with the ordinal variables, you can still do them, but I think bar charts are better for ordinal variables. What was an ordinal variable? Then it's not about your race. Let's say, are you black, white, Hispanic, Asian? This is not an ordinal variable. It's nominal because you cannot sort them from low to high. You cannot rank them. It's just words. So this is nominal. But if I ask you how much you like this class, and you have a scale, let's say 1 is I hate it and 10 is I love it, and then you choose 2, 3, 5, whatever it is, then actually there's an ordinal ranking here. So and you can do something like this. Or when you have these kind of variables, bar charts are probably better to do because bar charts give you a sense of order. And histograms are for interval ratio variables. So this is one example. Actually, you are not free to choose any graph that you want, but actually the levels of measurement matter. And other things you learn also matters. Now, today I will talk about this. And I decided to do this version. I'm not going to show you how to construct these graphs from the beginning, but I will show you what not to do. So I will start with the very bad examples, the worst examples of worst practices. And I'm not going to construct these examples. I just picked some of these examples that annoys me from the media sources and from different sources, and I will show you, and then we will talk about why they are wrong. So now for the participants that they are here right now, I will share my screen, but if you can, I will ask you if you can see my screen because it means it's also recorded too. So if you can see the Excel screen, please in the chat box say, yes, I can see it, because now I want to share my Excel sheet. Can you see these? Yes, great. Okay. So okay, so let's continue. So I want to start with this example, and I will show you many different examples today. And this example is about the question, what kind of a chart is this? And this is obviously a pie chart. Pie charts are these kind of charts in the circles, and the answers of the categories, what percentage of people answered what. They get their frequencies or percentages. In this particular pie chart, the question is about who are you going to support in the 2012 presidential elections. This is from the Republican candidates. Are you going to support Palin, Romney, or Huckabee? So can you already see what's wrong with this pie chart? So the idea with the pie charts is there is a question, and people answer there are different categories that they answer. And when you plot them on a pie chart, the percentages should add up to 100%, because the idea is that the area of the chart is 100%. Now let's look at this. Those who support Palin is 70%, who back Romney is 60%, Huckabee is 63%. This is already 130, 193%. What's happening here? This is a very bad pie chart. So you cannot make a pie chart for this. This doesn't mean anything. I mean, also, this is very bizarre in the sense that also look at the shares. I mean, look at the share for the 63%. I think this is greater than, is an image. It looks greater than 70%. Don't you agree? So, so this is very bad. So, of course, many people can understand why this is bad. Maybe you understand the pies, the slices, the percentages should add up to 100% in a pie chart. But many people are not very clear when they see these examples. Why do we have such a pie chart in the first place? Meaning, why did people who make this graph, why did they do it wrong? I mean, one idea is that they don't know how to do pie charts. Okay, some people might say, oh, they are trying to deceive people. That's okay, but there's a reason. There's a statistical reason that they are doing this error. And it's about some of the things I explained last week in this class. So what is the question here? I'll write here. I think the question is, who will you support in 2012 presidential elections? Something like this. This is, and then there are three categories here. One, are you going to support Palin? Two, are you going to support Romney? And then three, are you going to support Huckabee? Now, one of the interesting things is for this variable to be a good variable, it has to satisfy two properties. Do you remember what these properties are? One, the categories should be mutually exclusive. And two, the categories should be collectively exhaustive. Now, when you create such a poll, a survey question, and ask people, who are you going to support? Is it going to be a Palin, a Romney, or Huckabee? Well, honestly, many people can say, well, I will support Palin and Romney, but not Huckabee. Or they can also say, I will support Palin and Huckabee, but not Romney. Or some people can say, I will support Romney and Huckabee, but not Palin. And some people can say, I support all of them, right? So this is a problem, because if people can choose more than one categories in a question, then it actually invalidates. It does not satisfy the mutually exclusiveness criteria. It means the categories are not mutually exclusive. People who support Palin, it doesn't automatically say they do not support Romney and Huckabee, right? So, so if this is a problem, you cannot use this variable in a question. So, and also, this question also does not satisfy the collectively exhaustiveness criteria. What if there are people around there who say, you ask this question and they say, I'm not supporting any of these people. So I have another Republican candidate in mind, so I'm not going to support any of them. Whereas the other, like the category of other, is not here. So that's a problem. So in a nominal variable, what kind of a variable this is? It's a nominal variable. And this nominal variable, the way that it's constructed, the way that the question is asked, is problematic. And actually keep in mind, for many of your nominal variables, this can be the case. You might assume that in your nominal groups that you think in your mind that are mutually exclusive, they may not be mutually exclusive in reality. If you ask people, I gave you the example of religion last time. When you ask, are you Muslim, Christian, are you Jewish, are you Buddhist, etc. You assume that you might assume that people who will choose one category will not choose the others, but the reality, anthropologically speaking, sociologically speaking, can be more complex than you think. People might be inclined to choose more than one boxes. So how are you going to solve this problem? So in a good nominal variable, instead of asking the question like this, we can create 3 different questions, and we can use the dichotomous variables, our dummy variables. We can convert the nominal variables, as I said, the interval ratio variables, ordinal variables, nominal variables. There's an order here. So, and interval ratio variables are very strong. So every interval ratio, you can convert them into ordinal variables. Ordinal variables, you can convert them into nominal variables. But nominal variables cannot be converted into interval ratio or ordinal. It doesn't go that way. Nominal is nominal. The only thing you can do to save the research is to convert the nominal variable to a series of dummy variables, dichotomous variables. What were the dichotomous variables? 0, 1, yes or no questions. And this is a very actually important to understand. Instead of asking who will you support in 2012 presidential elections, you can ask 3 questions. Question number 1, will you support Palin? And the answers can be, let me write like this, yes or no. And then the second question can be, will you support? And I can actually make it, will you support Romney? And the third question can be, will you support Huckabee? So let me do like this so that you can see here. And then, and actually, when you ask, will you support Palin, yes or no? And here, from this graph, I can see that 70% says yes to this question, and 30% says no. I can say 70%, 70%, and 30%. And will you support Romney? I can see that 60% says yes, 40% says no. And will you support Huckabee? And 63% says yes, and 27%, 37% says no to this question. And once you do this, now actually you have a good variable. It can still be better. I mean, because people doesn't have to say yes or no. Maybe they haven't decided yet, etc. We can deal with them later. But now what you can do, you can actually make a good graph for this. You can use 3 different pie charts if you want. But if you did as you will remember from the preparatory videos, making multiple pie charts is not a very good idea. Actually, pie charts are becoming more and more, they are not, for statisticians and data analysts, they are not the best graphs. Let me put it this way. People don't like pie charts that much. For various reasons, bar charts, for instance, gives you more options, and it's better for comparative reasons. So what if you want to do a bar chart for this, what you can do, you can highlight the section that you want to do a bar chart. In Excel, you can go to Insert, and then you can say, these are the charts areas. You can say, I'm going to make a chart, and these are, the bar charts are the vertical bar charts that we are doing. In Excel, they are called columns. So you will do a 2-dimensional column, and here you go. This is you can change the chart's title, 2012 presidential elections. Here we go. So this is actually a better graph, now actually it doesn't have the problems that you see in this pie chart, and you can compare them. And here I can see for people who say yes are marked with blue, and when I look at the Palin, the Palin has more support than Huckabee, and then Romney. And it gives more information than this graph, and this is the correct graph. This is completely nonsense in this particular example. So you can think that this was this is just an accident. So it's just an error. No one does these errors, but you can see that it's coming from a TV and in the news sources. And let me assure you, people do these errors all the time because they don't know how to construct good variables. And these people who work for the TV shows or for the news agencies, for journals, magazines, there are usually data analysts there, but they don't even know how to do a proper pie chart because they don't understand what it means to be a good variable, okay, the kind of properties you have. Let me give you another example about this. This is the second example. So here, this is very recent about COVID-19, coronavirus worries. So here, I think the question is, when you think about COVID-19, the coronavirus, what are you most worried about? Are you worried about getting it? Are you worried about your family getting it? Or are you worried about the economy, right? And you can see here, again, they put on a pie chart, and getting it is here 48%, family getting it 62%, and the economy is 68%. Now, the first thing you should recognize about this pie chart, again, this is nonsense. It doesn't, this pie chart is not a pie chart even. So when you do things like this, people will laugh at you. And who knows how to read, they will immediately see that you don't know what you are doing because this is terrible. A pie chart, the percentages should add up to 100. Okay, sometimes it's not exactly 100, 100.1 or 99 because the way that percentages are rounded, and we can tolerate those kind of things. But this completely shows you that you don't know what you are doing. Again, you have to. The problem is the same with the previous example, because when you say what are you worried about, these options are not mutually exclusive. You might be worried about yourself getting it. At the same time, you might be worried about your family getting it. At the same time, you're worried about the economy and how it will affect you and everyone else. So people can choose multiple of these, and they do choose multiple of these. In that case, you cannot ask this as a single question. Then as this, what kind of variable is this? What's this level of measurement? Is this interval ratio? No. Is this ordinal? No, I cannot rank these. So there's a nominal variable. And in a nominal variable, if people can choose more than one options, what can you do? You can turn them into 3 different questions and ask it as a dichotomous variable, 0 or 1. The first question, are you worried about getting it? Yes or no? And then 48% might say yes, and 52% might say no. Are you worried about your family getting it? Yes or no. Are you worried about the economy getting it? Yes or no, etc. Then you can create these multiple variables, and you can create either pie charts or bar charts about them. For comparative reasons, I think bar charts are better for comparative reasons. Then you can see the ups and downs and how the comparison will be much easier than this. Slices. I will talk more about that in a minute. So that's the kind of my initial points about pie charts. Okay, so I'm not going to do the same thing here. Actually, if you want to do, you can easily say you can put the category C, family getting it, and the economy, and you can easily say you can create the. Or let's do it this way. Let's put the variables in the y-axis as we did last time. Let's be consistent. Now I created 3 variables, and then I'm going to say yes and no. And here the percentages I see here are the yes. So getting it is 68%. The family getting it is 62, and the economy is 68%, and then this should be 52. You can also, I'm writing like this, but because they will all add up to 100%, if you want to learn more about Excel, because they will be all adding up to 100%, in Excel, what you can always do, you can always say is equal to, that's how you, let me do it like this so you can see, you can say is equal to, you can say this minus this, and then it will just calculate it for you. You're not supposed to know this, I'm not teaching it to you right now, so don't worry, that's not the purpose of this lecture. I'm not teaching you how to use Excel, but I'm just doing it in case you would be interested. You can pick up something, because I normally teach this in my courses, but not this year. And here we go. This is our new better chart. This is, I can change the title. Actually, I can even make it more fancy by changing the color like this. So biggest COVID-19 worries. And here we go. I can see the yes and no. Yes is blue, no is orange. And then now I have lots of information. Now I can see actually the difference between the getting it and family getting it and the economy. As you can see, the worry goes higher and higher for people who says yes in this category. So this is the correct graph, not this one. Okay. So let me move to a third example. So meet James Barber. This is an example from UK, United Kingdom. And James Barber is a politician. He's a candidate from Liberal Democrats in UK. And this is his election campaign pamphlet. He says, how you voted in Dulwich and West Norwood last time? And he says, these are the other parties. This is Liberal Democrat. He's a Liberal Democrat himself. And he says, Labour is the winning party, then Liberal Democrats, then the Conservatives, the Greens, UKIP. And then he has a point. He said, well, look at the graphs. They cannot win here. So his point is, if you want to beat Labour Party here in Dulwich and West Norwood, vote for me, Liberal Democrats, because you see I'm very close to passing them. So question number one, well, what kind of graph is this? And this is, like we did last time, it's a bar chart. So it's a bar chart. In Excel it says columns, but it's a bar chart. So the question number two, is there something wrong with this bar chart? Look at this. Let's look at this more carefully. Now, the idea with the bar charts is that the heights of the bars, the heights of these bars should represent the frequencies or the percentages. I will talk about the difference between frequencies and percentages later, but that's the idea. And and they should be representative. So now, are the height of these bars, do they really represent the percentages? Look at Labour. This is 46%. Liberal Democrats, 27%. Conservatives, 22%. Wait, and Greens, 3%. Wait for a second. So this difference between Greens and Conservatives, which is around 19%. This is 19%. And this is 5%. It's almost the same difference, 5%. And look at this. This difference is, and compare with this one, 9% difference. So as you can see, the graphs, the height of these bars are completely not in proportion with the percentages. So you cannot do this. You cannot simply change the height of the bars in the way that you want. That's not how bar charts work. So you need to actually do this properly. So if you want to do it, we can do it. Let's do it again. So this is Labour, this is Lib Dem, this is Con, this is Green, this is UKIP. And then in terms of the percentages, how you voted last time, and this is 46%, 27%, conservatives are 22%, and green is 3%, and UKIP is 1.5%. Oh, it just rounded up. So if you don't want it to round up, you can always come to, you can do a right click and you can say format. I don't want you to round my numbers. Decimal show one decimal place. Here we go, 1.5%. And then you can always say insert and click to the columns, and you can choose the columns. And actually, this is the right one, how you voted last time. And this tells you a slightly different picture than this one, because here you can see, actually, if you want it to be similar to what he was doing, you can turn it to something like this. And let me change the color a little bit so you can read, so that you can read. Here we go. And actually, it's not a good idea. I always want to see the y-axis here. Now, I just tried to do it in the way that he's doing for you to see the difference. As you can see, the difference between Liberal Democrats and Labour is high. And if to beat the Labour, actually, conservatives are also very close. They're not very different from Liberal Democrats, only 5% difference votes. So, okay, these do not count. But actually, the Barber's kind of pamphlet is misleading. It doesn't correctly represent what's happening in this region. But also, one problem that I see in this chart is I always want to see the y and x axis. So here x is not the problem because he put as a label here, but the y axis, always want your y axis. Okay, in this class, one of the things you need to learn today, to better read graphs and data, you always want to see the axes, and you always want to see what this variable is, okay? Because the devil is in the details, and these details are not even the details. Look at the y-axis clearly. So even in this graph, I'm not going to do it this way. So I just show you that you can do it this way, but it's better to always keep your y-axis like this, to see that there's nothing going on, there's nothing bad going on right there. I will explain why this is important in a bit. So this is better. I want to see the y-axis, my point. And then we make the point. So this graphic is completely misleading. It's not a good bar chart. So let me show you how this is relevant. This is about a COVID-19 case, a recent example, and let me give some more international examples, some of the non-English from some of the non-English speaking world. This is Argentina, and this is the tests per million inhabitants. So for 1 million citizens, how many tests they are doing. And Argentina is comparing themselves to Brazil, and this is USA, Italy, this is Germany, and Norway. So, and this what kind of a graph is this? It's a bar chart again. So what's wrong with this bar chart? Is there something wrong with this bar chart? When I look at it, one, I don't see the y-axis. I always want to see the y-axis. I don't see it. And when I don't see the y-axis, I always get suspicious. Why don't I see the y-axis here? And that's something else is very suspicious. I wonder about the heights of these bars. Now here, look, Argentina is very close to USA here. But look at the difference between Brazil and Argentina, 258, 330. So there's like less than 100 tests here. And this is from 330 to 7,000 is this. And this is from 7,000 to 1,400 is this. So in a way, this difference, this height difference is 7,000. So 7,000 difference from here, it should be to nothing. So this is crazy. This is completely nonsense, this chart. So if you want to see the real picture, you need to do it yourselves. So let's do it. Brazil, Argentina, this is USA, and this is Italy, and this is Alemania, this is Germany, and this is Norway. And then, so you can then type the test numbers here, 7,000, 1,400, and 15,700, and 22,300, and tests per million. And then let's create the bar chart again. Insert, bar, not line, bar chart. Here we go. So this is the real figure. So Argentina should be using this figure. You're here, okay? Not here. So this is completely misleading. It's giving the impression as if Argentina is doing lots of tests. In reality, even compared to, I mean, this is per million inhabitants. And they're not, they at the time when they were doing this, they were not doing enough, okay? So this chart is completely misleading, and it's misleading because a good bar chart, the heights of the bar chart should be representative to the frequencies or the percentage. The previous example was about the percentages, and this example is using the frequencies, but it's the same thing. I mean, the logic is the same, okay? So that's the idea. Let's do another example. This is from Russia. Let's give one example from Russia. This is the COVID-19 case again, and as you can see, Russia is flattening the curve. This is the daily COVID-19 cases. As you can see, Russia, this is March. So starting with March, the cases started increasing. But do you see this slight curve here? So it appears as if they are about to flatten the curve. Good for them, except I don't see the y-axis here. So when I don't see the y-axis, it makes me very suspicious. So to save time, I put all of these numbers here instead of typing one by one and losing time. I already typed them here. And as you can see from March 1st, it starts with 1, 7, 11, 40, it goes, and all the way to 22,337. Let's do it ourselves to see how Russia is flattening the curve. Here we go. This is how Russia is flattening the curve. It's not flattening. It's exponentially increased. The flattening has not even started. So bad news. So you cannot stop COVID-19 by just changing the height of the bars. I hope the world work like that, but it's not happening. So at least let's do the statistics properly. So this is Russia's number, and if you want, you can put the numbers here too, and you can there are lots of, you can play with this, and if you would be interested, I can show you there are different options that you can do for this bar charts to even to look better. But my point is always pay attention to the y-axis, okay? So don't take the graphs as they are given to you, and when you construct your own graphs, don't paint it yourself. I mean, you need to use software to do this, and always try to show the y-axis like this. I want to see this y-axis. I want to see these numbers here, and when I see the numbers, I want to make sure that the numbers are increasing in the same pattern. In the same way, 0, 500, 1,000, 1,500, 2,000, 2,500, good. The same scale, it's very good. And then I can see in the x-axis too. This is y-axis, this is x-axis. I want to see the time, the March 5th, 6th, 7th, 8th, 9th, 10, it goes all the way up to 31. Very good, so I can rely on this. Okay, so that's the idea. You might say, these are very simple things. Why are we losing our time on these kind of things? But do not assume, because you cannot believe what's happening around yourself. So I will give more examples about these kind of things. So I think looking at these bad graphs and the bad charts and the misleading graphs is a very good way of understanding how to avoid these errors, okay? So let's look at an example from US. Okay, so this is from Georgia. And this is coming from a 5 counties with greatest number of confirmed COVID-19 cases in Georgia. It's from the Cobb, DeKalb, Fulton, Gwinnett, and Hall counties. I don't know anything about that. So this is interesting because the chart below represents the most impacted counties over the past 15 days and the number of COVID cases over time. So, okay, so this is an over time. And here, each county is represented with a different color. And this is, it starts with the April 28 and to May 9. And as you can see, the order of the counties changed. You can see here on April 28, Hall County had the highest, but let's say on May 7th, it is the Fulton County, etc. You can see those kind of changes as well. And then when you look at the chart, over time, you can see that the cases seem to be decreasing over time. And it's also good that this time I have the y-axis. See, 0, 50, 100, 150. And I assume that the heights represent the data, so I hope there is no problem with that. Okay, so far so good. So is there something wrong with this graph? And yes, there's something very wrong with this graph. And this time, pay attention to x-axis. What's wrong with the x-axis? This one, isn't this just time? Yes, but look how time is going. April 28, then April 27. Then April 29, May 1st, then April 30. What's happening here? Then May 4, then May 6, then May 5, then May 2nd, then 7, then April 26. Coming back. So the time is erratic here. I mean, you cannot do this. I mean, the time should be going from day 1, day 2, day 3, day 4, whatever that is. You cannot simply change the order of time. You cannot do this because this is not a nominal variable. If this was a nominal variable, you could have changed their orders. That's fine in a nominal variable. If these were not time points, but this was blacks, Hispanics, etc., or religions, you can change their order, fine, because there is no order. Okay? In the previous questions, if we did with the GOP candidates, if I put this Romney example here, Palin here, it's not going to change anything. There is no order here. They are nominal variables. But this is not nominal. This is time. Time is either interval ratio variable, if the same distances, if we talk about it, or there is this ordinal aspect to it too. Because the distances at time is exactly the same, we can safely assume that it's an interval ratio variable. And then it means you cannot simply change their orders. There's a ranking order. It has to go from the lowest to highest. It needs to go from the earliest time to the latest period. Okay, you cannot change this. So when you change it, you arbitrarily create this illusion that the cases are decreasing, but it maybe it's not decreasing. This is such a big problem. So pay attention to your y-axis and pay attention to your x-axis in all of these graphs. What are these x-axes? Okay, so let's move on to the next one. This is an example that I love. This is about gun deaths in Florida. And some of you maybe are interested in criminology and the homicides and violence, etc. And here, this is good from 1990s, 2000, 2010. And this is the number of deaths, murders committed using firearms. And in 2005, Florida enacted its Stand Your Ground law. And I don't know if you know the law, but it means to kill someone when you feel that you are in danger, then you don't need to retreat anymore. You can just kill them, etc. And then the idea is, look at this after 2005, what happened to the number of homicides. Now, here, if you look at the chart, you might think that it decreased. It's giving you the impression of a decrease, but look at the y-axis. So 0 is here, and 1000 is here. It's created upside down. So in a way, here, after 2005, in reality, the number of gun deaths are not decreasing. They are increasing. It was 500, somewhere around 500, and then immediately it went over 800. But the way that the graph is constructed is giving you the exact opposite image. You cannot do that. It has to go, there is an order here, so it has to go from lowest to highest, not highest to lowest, okay? So in the ordinal ranks or in interval ratio, you cannot draw the, unless there's a substantive point that you're trying to make, you cannot simply change this order because it becomes counterintuitive. When we see a line decreasing, we assume that the variable that we're observing is decreasing over time. I mean, it's also, we don't see the time periods, but I think it's fine. These dots are represent every year. I think it's fine. But this graph should be the opposite of what it looks like. Actually, there's an increase in this period. And it's just giving this the opposite image by switching the y-axis. So this is not a good example. So, but I think this is still better than this one. With this one, I have no clue what's happening. So this is again, Florida. So another Florida case. This is not about guns. This time it's about coronavirus. So in Florida, they might need some good data analysts and statisticians. So if you want, you can apply for jobs there, maybe if you want to move to Florida with your CV and with your grades from this course. If they're interested in hiring good data analysts, of course. The idea is, look at this. This is the confirmed cases of coronavirus. This is about the June 17, June 18, June 19, June 20, June 21. And look at the numbers, 3,207. I see a decrease and an increase moment. But if you leave the label, it's weird because this is 3,207. is higher than 3,822. This is higher than 4,000, and this is less than 3,400. It's not even the reverse. First, when I looked at this, I said, oh, they also did it in reverse. It's not even that, because look at 3,400, even if it was going the opposite way, it should have been somewhere here, and 2,900, it should be maybe here. It's not. This is completely crazy. So I don't understand what's happening here at all. So I will just do the data. In Excel, it may understand when you type things like 6, 17, 18, it automatically understands that you're dealing with time. So it says, it puts the time there. And here we go. And then this is the Florida confirmed cases. And then I just put the numbers here, 3,822, 4,490, and here we go. I just wrote the numbers here. I don't know if you can see. So what I will do, I will highlight these. I will go insert. I will go to the charts, and I will do this, my bar chart. Here, what it should look like. Oops, sorry. So for the scales, here we go. Let's do it. Here we go. Okay, so it should be like this, not like this. Okay, this is the trend. Again, I mean, I'm not trying to make a point about the what it means substantively. I mean, why this is important, etc. My point is, this graph is wrong. Okay, and the graph that we created now on the left is right. So pay attention. But these two graphs will give you two different images. Here I can see that they were rising and started declining. Here I can see that it's first declined then started to rise, which is the opposite picture. Okay, so we need to pay attention to this. Now, sometimes, now the next example I will show you is a more complex, is a very interesting complex case. And it's complex for a variety of reasons. Let's do this. Now, this is about Kansas, and this is about there are two line charts here. Now, actually, the line charts, when we deal, many of the examples before, we could have used the line charts in the sense that if there is a time dimension, especially on x-axis, if there is days or years, etc. Instead of putting them in bars, you can also show them as a line, so that we can see as a time series graph or a line graph, something like this. Here there are two. There are two variables here. I can see that there are in Kansas, these are the 7-day rolling averages. So it's the average of the 7 days, average of that week. And these cases per 100,000 population. Okay, so how many daily COVID-19 cases we see? And then here we have two lines. The red one is mask. It means the mask counties. So this is about the counties where there is a mandate to wear masks. And then there's the blue one. In the blue one, there's a mandate of, there's no mandate of mask wearing, okay? So, and as you can see, actually in those where there is a mask mandate, the line goes much below. But pay attention here. Here we don't have a single y-axis, we have two y-axes. This is one for masks, and this is two for no masks. And it's bizarre that, why do we really need two y-axes here? Sometimes we can do this, but we do some very spatial circumstances. When you have two y-axes, it's because, let's say, on the left hand you show something in dollars. On the right axis you represent something in terms of yen or ruble or something that you cannot directly compare. So maybe the scale is different. So you put that scale there, and then you can see the relative changes over time. That's fine. But here it's about the daily cases of COVID-19, and the numbers are not that much different from each other. So why do we have two? And also what's bizarre is you have two, and here the mask, the red line here on August 3, this is 16 cases, but the mask is much higher. No mask, blue line, is just 9 cases. This is wrong. You cannot represent the data like this. I think the true data should be this. So actually now we put on the same y-axis, and you can see this is the mask wearing mandate, the counties where masks say yes, this is the kind of the trend, and in no mask, this is the kind of trend. So so this is the one on the right is a better graph, is a better graph. But of course, you might say, well, what's happening here? This is quite an interesting graph, because it tells us that in regions where there is a mask mandate to wear mask, there are more COVID-19 cases. Can you see that? And no mask. Now, I will ask you another question. Let me assure you, the one on the right is a better graph, statistically speaking. Now, why is this happening? Can we use this graph and say, hey, look, wearing mask is actually not good, because when you wear the mask, there is more COVID-19 cases. People will say, what? How is this possible? And then you can give the example of Kansas. You can say, look at the mask wearing, the counties, the counties where when there's a mask wearing mandate, you can see that the cases are much higher. Can you show this figure and say, make that point? So wearing masks are bad for COVID? Now, yes or no? The idea of yes, well, you can try to make that point, but then you need to understand, you need to think more carefully about what is the dependent variable, what's the independent variable here. Sometimes in social sciences, it's not easy to, in certain examples, it's quite easy to understand what's the dependent variable, what's the independent variable here. But sometimes independent and dependent variable, they create a feedback effect. So they interact with each other, and from different angles, they can switch their positions. Now, what's interesting is, I think what's happening here is, in Kansas, why do certain counties have a mandate to wear masks and why others do not? One explanation is, when there are lots of COVID-19 cases, when there's a cluster of COVID-19 cases, when the cases are becoming higher and higher, then maybe the health secretaries and the governors, or maybe the mayors, they said there should be a mandate here because the cases are so high. So because it was going high, you started to have mask mandate, and because the cases were low in others, you had a no mask mandate. So in a way, the mask mandate in this case can be a dependent variable too. So initially, I think it was a dependent variable based on the level of COVID-19 cases. But then it becomes an independent variable. It starts to affect, it starts to have an effect too, as you can see in the mask wearing mandates in countries where people wear masks, the cases started to decrease over time. So here, the independent and dependent variables switched. Now wearing masks and not wearing masks, it has an effect on COVID-19 cases, etc. So, so two lessons here. One, pay attention to the y-axis, and if there are two of them, make sure that you know how to compare them. But two, don't jump to the conclusions immediately, because you need to know your independent and dependent variables. It's an important thing. What's the independent variable here? What's the dependent variable? And sometimes there's no relationship with that. We will do a lecture on spurious relationships and other kinds of relationships. And then you will see sometimes there is no relationship. You assume that there is a relationship, but there was no relationship. I think, or maybe there is a relationship, but the relationship was due to some other cases. And last week, we in one of the preparatory videos, it gave you many examples of this. One of the examples about, I think, the Ben and Jerry advertisements. They come up with a commercial in May about Ben and Jerry ice creams, and then they look at the trend of ice creams until May, ice cream sales, and after May, June, July, August, etc. And when they see this huge rise in sales, they can say, look, this is before the commercial and after the commercial, so the commercial worked. But maybe it's not the commercial what worked. Maybe it's because summer came and you make the commercial just before summer. So it's maybe not the commercial's effect, but it's just the summer effect, right? So there are other things we need to take into consideration. I will give you a couple of more examples, and then I will be done for this section, and then I want to review a couple of good examples too. The other two things that you need to watch out, especially in the case of the bar charts and pie charts, is now with infographics, these kind of visualizations of data are becoming more and more fancy. In the preparatory videos, it gave this example, a similar version with the Mac computers, the Macintosh sales, and like the previous users who were buying what. This is an example, it's a real example also. It's from the new iPad batteries. And here, again, this is not simply an image, this is actually a bar chart. But instead of putting the bars, they decided to put the batteries. Now, watch out every time that you see something like this, because there's a trick here. Let me type here. We don't have any data here. We don't see any numbers, but a previous iPad and new iPad. And the batteries are, and then the battery size. Let me put it here, battery side. I don't know the numbers, but I can see that's 70% larger. So if the previous was 100, this is 170. So I just put like this. So what's interesting here is the bar chart should have looked like this. Okay. Now it should have looked like this, but it looks like this. Let me actually make them comparable in terms of the size. So isn't this and this identical? And my answer is no, they are not identical, because here, not only the y-axis, not only the height, but also the width also increased. Do you see that? So technically, when you increase the width, the area didn't increase by 70%. The area increased by more than 100%. So it's actually a huge increase, maybe 140%, etc. So when you create these kind of images, when the width are not equal, it creates on the brain with an image, it creates the illusion that the perceived effect is greater. So this is known as the lie factor. So so you should avoid this. So the width of your bars should always be the same. So that's one of the important rules that I want to say. And always avoid this kind of infographics. I mean, if I were you, I would avoid them as much as I can. They are not helpful, and you wouldn't be able to put the y-axis there. Again, we need the y-axis for several reasons, as like we have been talking about, and so it's not a good idea. And also now with Excel, SPSS, R, with all these statistical packages around there, you can now make all of these three-dimensional figures as well. They look fancy, but again, now people who designed these three-dimensional images, they didn't think about the consequences in terms of statistical thinking and the data analysis purposes. They look good, but actually they create lots of problems. So I would suggest that you avoid them. Let me give you one example. Now, this is an example from two pie charts, and these pie charts are coming from this table. There is item A, item B, item C, item D. As you can see, if you do a three-dimensional chart, like there's a three-dimensional version, as you can see, item A and item C, can you see that because I created a three-dimensional image and then I just change its position a little bit, they look similar? Can you see that the share looks similar? But it's an illusion because this is 5%, in reality this is 11%. And here, look, these two of them, the item D and item B, they are 42%. But if you create a three-dimensional image, do they look the same to you? This looks greater to me, item D than item B. So three-dimensional images, when you play with their perspective, it might not represent the values as they should. So the slices, they do not be proportional. They are no longer proportional to what they are supposed to be. So you need to watch out those kind of things as well. Let me give you two more, the last example from here, then I will just go over one thing and then we are done. And then I would say, watch out. Until now, we talked about the frequencies and percentages. And I would say, watch out what is being presented in the y-axis. It's not only if there's a y-axis or not, but what is that? Okay, so this is an example about the percentage change in church membership in UK. And this is about, as you can see, the Trinitarian churches, they're in decline. Non-Trinitarian churches are increasing, but Muslim churches, meaning mosques, can you see this increase? Like 500% increase from 1970 to 1994. And the Sikhs, there's a slight increase, and the others are not visible. There's no change, probably zero. So here, by looking at this image, I would say in this country, the churches are, the Muslims are like increasing dramatically. But what is the y-axis here? It's a percentage change. Every time that you are given a percentage change, what percentage growth that is? Always pay attention to the absolute raw scores. What is the absolute frequency here? Because let's say if there's a one mosque before in 1970, and in 1994, if there are two mosques, the percent change is 100% from 1 to 2. So percent change is very sensitive to initial scores. That's why if you look at the absolute frequencies, actually, I prepared it for you here. Actually, this was the real data. This is the Trinitarian churches. This is their decrease. This is the non-Trinitarian churches. This is their increase, and this is the Muslim increase. So there still you can see the increase here, but this 500% increase is not as dramatic as this one. So always pay attention to the absolute figures and the relative figures. This is especially important if people are talking about economy, how the economy is growing. Any government that takes over an economy after a big crisis, they can document huge growth rates because the previous year the economy collapsed, and after that, whatever you do, it will be a huge growth. Huh? So this is like, there are these kind of things that you should be paying attention to. Okay, so these are some of the things I wanted to show, like the bad examples, etc. And I would like to conclude this by showing you some other real examples, but this time I will use my last 5 minutes to go over this. So I hope you can see I hope you can see my web screen right now. So I searched for Guilford, Guilford, North Carolina, COVID-19. There's a Guilford County, North Carolina.gov. They have this COVID-19 dashboard you might find interesting. So there are some nice statistics here that I watch. Can you all see my screen right now? Can you all see the screen? Let me see. Okay, great, thank you. Here, where can I get tested, etc. But here, there's one interesting thing. This is here I can see the confirmed cases of COVID-19 in North Carolina. And here I can see, I'm looking at the y-axis, 0, 2,000, 4,000, 6,000, 8,000, very good. That's what I want to see. And I look at the x-axis, and the x-axis, it looks to be in order, and the intervals they appear to be similar. So I can trust this. So I can see that COVID-19, we see an increase, and we are starting to flatten it, maybe. What do you think? So it's not very clear, but maybe. So at least we see that it's not like increasing exponential like this. There is a flattening here, which is probably good news for North Carolina. But we have to look. So this is again a line graph. This is a line graph showing the total hospitalizations. On the x-axis, I can see the dates from May 2, May 22, June 11, etc. And then here I can see the total hospitalizations. They are increasing linearly. So I don't know what is the so I don't know if there will be any flattening or if it will go like this. We cannot say. Later on in this course, we will do some projections about it, but not now. The third bar, this is interesting, the patients by age and gender. Now, this is positive test percentage by age, different age groups. When you're presented these kind of different age groups, one of the things I want you, this is not perfect in that sense. I always want to try to make these age groups the same intervals, 0 to 17. So this is 18 to 24. So there's 17 people here. There's 6 people here. 25 to 49. So there are 24 age groups here. When I say people, previously I meant age groups. So this is 50 to 59. So because these categorizations will be very sensitive to these intervals, I would do them equal. So this is not for me a very good example of that because they are not equal. For instance, here, it creates the image, it creates the perception that the positive tests are the 25-49 group. Can you see that? This group is the highest percentage, 41%. But also this group has almost 25 age categories. Look at them. None of them are 25 age groups. Like this is 9, this is 15, etc. This might have a big impact. I would make them equal to see exactly which age group has more positive tests. And this is the positive test by age and gender. And here they put the same thing, this graph here, and then they try to show it by also in terms of the gender. So I can see F for females, males. It's the first time I see trans in these statistics, actually. Good. And then U, it's not clear what that is, but maybe it can be another gender group or maybe undefined or if someone, maybe they didn't want to share their gender, etc. Or unknown, something like this. But we can compare, and the positive tests, I think there are more for females and the age groups are here for the lower age groups. But then when we come to 60, 75, maybe more males have, have positive tests. Here we can see the same, a similar graphic by, this is the COVID-19 deaths by race. In terms of race, we see whites, blacks, Asians, Native Americans, and others. So this is a nominal variable. They use the bar chart, which is okay. If you're using a bar chart, the idea is there must be some space between these groups. Don't make them contiguous like this, because histograms are continuous. So here there should be, I would always put that space in between. They didn't put it stylistically. I think it's not a good practice, but that's okay. Here I can see that the deaths are, 49% of the deaths are in Guilford County, North Carolina are blacks, are whites, and 38.5% are blacks. But here, so you need to put these numbers also in context, because you also need to look at what percentage of Guilford County is white and black. Okay? If it is, if they're not 50-50, they're not 50-50. Let's say if in Guilford County only 20% of the population are blacks, and if 38% of them are dying, and so it gives you a different kind of picture. So you need to compare these numbers with the actual populations. So so you can look at these ones, and I will show you these two graphs. You can skim the others yourselves too. These are the confirmed cases in Guilford County, the running total. Until now, this is the part where we were discussing whether or not we are flattening the curve, and this is the daily positive tests. So as you can see, there is every day it goes up and down. So I can see that until July, there is a general increasing tendency, but after July 4th, etc., it started to decline. And actually, this is when also there was a mask wearing order, I think, by the mayor. It came around this times, and it started to decrease. And this decrease still continues, but this is an anomaly period, I can see. Do you know what's happening here late August, and why it started to increase? We don't know. If that's the dependent variable. Any kind of potential answer can be the independent variable, but I think one answer is that the schools are opening now. So this is the where we are looking at this. So okay, so I think our time is up. So today I didn't teach you anything new, but what I wanted to do was to go over some of the ways that we represent the data and graphs, and to link it with some of the things we learned so far. We didn't cover everything in the lecture, but in the preparatory videos, you saw more examples too. If I had time, I would focus also more on the histograms as well. So make sure that you understand the notion of histograms. The idea with the histograms is you use it for interval ratio variables, and it shows you also the distribution of cases in terms of percentages. But the data cannot be nominal. The data cannot be ordinal. It has to be interval ratio data. It has to be in numbers. So I think that's it for this week. We will, after you watch this video, you can, I will be uploading this video by 5 p.m. today, and you can watch it there too. And after that, after you finish this, you can do the discussion again. And also there's a quiz waiting for you. I will be updating the quiz and uploading it later today. Okay, for any kind of questions, also don't hesitate to email me or put it on the discussion board. discussion board is probably better, then other students also see it. And then when I respond to it, they will also see the response collectively. And if you see any other kind of these kind of graphs which are bad or misleading, etc., don't hesitate to share it. Put it in the discussion board. I would love to see new examples and what you think about them. And as we go along, for everything that we learn, I will try to do my best to show you some good practices and relatively bad practices of how to do that. Okay, so thank you very much. See you next week.